So the last part of this lecture is measuring autocorrelation. We measure autocorrelation by using Durbin-Watson statistics, and I directly jump into the formula without going into the discussion that what is Durbin-Watson statistics and why do we use it. Uh, anyways, Durbin-Watson statistics tells us that is there any autocorrelation or not, that data is collected over a same period of time or there is difference. So we define null and alternate hypothesis. In null hypothesis, we say that the positive autocorrelation does not exist, and in H1 we say that positive autocorrelation does exist or present. And this is the formula for Durbin-Watson statistics. You know E is error, which is y minus y hat and then E square, and it starts from 2, which means that E2 minus E1, E3 minus E2, E4 minus E3, it continues, and then we get D. After calculating D, this is the rejection and exception criteria for Durbin-Watson T statistics. There is a table back of the book with k equals to 1, k equals to 2, where k is representing number of independent variable. Like here in our example we have x and y, we have only one independent variable, so k equals to 1, and dl and du for each k we have dl and du, for each k we have dl and du. Here we have number of observations. In our case we had n equals to 6, so we see where it is 6, 1, 2, 3, 4, 5, 6, k equals to 1. Here we have dl and du, these two values in the table you can see corresponding to 6 and corresponding to k equals to 1, because independent variable is 1. That would be our dl and du, and we will calculate d. We will compare decision rule reject h naught if d is less than dl. If d is less than dl, here reject h naught. If d is between dl and du, then inconclusive, we cannot say anything. And if d is greater than du, we say do not reject h naught. So this is how we take the decision, and you can plot time and sales here, and you can see the coefficient of regression. This is your regression equation, and this they have solved this example through Excel by using this formula, and we applied the same formula on our example which we are solving here. Through their example they had one independent variable, k is 1, their n is 25. So through the table from back of the book, as I explained it in the previous slide, how to calculate, how to see dl and du, you compare dl and du with your capital D. So capital D is 1.06, which is here, so we reject h naught since d is less than dl.